In pursuit of transferring technical knowledge and just to gear up the new engineering entrant, myself Pranav is here to deliver today's presentation, Power Transformer Part 64. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with importance of measuring density or API gravity of crude oil. Density of crude oil is a highly temperature dependent parameter where the density of all types of oil would have to decrease as temperature increased. It is rather to measure for determining the fluid how heavy or light as compared to liquid water, and the standard unit of measurement for crude oil density is API gravity scale, that is degree API. The higher degrees of API gravity would represent comparatively the lower density crude oils, that is lighter and less dense crude oils. Whereas the lower degrees of API gravity would represent comparatively the higher density crude oils, that is heavier or thicker, that is dense and viscous crude oils. Crude oil density is a crucial property as the fluid is being classified by its density into the following categories. Category: ultra heavy crude oil, whose density in grams per centimeter cube is rather greater than or equal to 0.925 gram per centimeter cube or cubic centimeter. Heavy crude oil, that is greater than 0.9 gram per centimeter cube and less than 0.925 gram per centimeter cube. Medium crude oil, which is greater than 0.85 gram per centimeter cube and less than 0.9 gram per centimeter cube. Light crude oil is less than 0.85 gram per centimeter cube, that is density. Now, crude oil category, if represents to API degree and density per gram per centimeter cube, then ultra heavy is rather less than 10 or density is greater than 1. Heavy 22.3 to 10, but density is 0.92 to 1. Medium category rather 31.1 to 22.3, whereas density 0.87 to 0.92 gram per centimeter cube. Light crude oil is greater than 31.1 degree API, but its density is less than 0.87 gram per centimeter cube. Light crude oils that are normally have to compose with a higher percentage of light hydrocarbons, and the total ongoing refinery distillation processes would be rather much more easier and less expensive. The light crude oils with low carbon, high hydrogen, and high API gravity are normally rich in paraffins with having slightest amount of asphaltic materials. Heavy crude oils with high carbon, low hydrogen and low API gravity are normally rich in high weight percentage of asphaltene, that is, the nonpolar and non-volatile components of crude oil. Asphaltenes in crude oils have therefore to predominantly containing of high molecular weight condensed aromatic components, including heteroatomic atomic molecules of different elements. Again, I repeat, asphaltenes in crude oils have therefore to predominantly containing of high molecular weight condensed aromatic components, including heteroatomic atomic molecules of different elements. Heteroatomic molecules of different elements. Heteroatoms are those atoms other than hydrogen or carbon found in the molecular structure of organic compounds. Asphaltenes are being the non-uniform and complex in their chemical composition, which thus to constitute with aromatic compounds of high molecular weight that usually have to contain heteroatoms such as sulfur, nitrogen, and oxygen, as well as metals such as vanadium, nickel, and iron. Asphaltenes of high molecular weight, if present as a component of crude oil, then that would have to create high viscosity, causing the subject oil much more heavy. However, there would have a perfect correlation between crude oil viscosity and the relative concentration levels of chemical groups as present in the oil, which include saturates, aromatics, resins, and asphaltenes. Heavy crudes, as that contain high concentrations of bitumen, sulfur, and other metals, so it is rather to involve further extra cost making additional refining processes to create quality product from these crudes. The ASTM D1298 12B 2017 has intended to put forward a standard test method for accurate determination of the API gravity, density, or relative density, that is specific gravity, of crude petroleum, liquid hydrocarbon products, or mixtures of liquid petroleum and non-petroleum products using a standard temperature of 60 degree Fahrenheit or 15.6 degrees centigrade. It is important to note that the specific gravity of crude oil would have a direct relationship with the level of sulfur content. As a matter of fact, the specific gravity of crude oil would have become higher as corresponds to the presence of higher level of sulfur content. Physicochemical treatment of crude oil. The crude oil is not only be a mixture of comparatively volatile liquid hydrocarbons, but it also contains some sulfur, oxygen, and nitrogen. Those elements other than hydrocarbons would actually exist as a large variety of complex molecular structures, and some of which cannot be readily identified. Out of these elements, sulfur is the most abundant element, which occurs either as elemental sulfur or in compounds such as hydrogen sulfide, H2S. Any occurrence of direct combustion of sulfur containing oil that would therefore have to emit large amounts of sulfur oxides into the environment, causing serious environmental pollution. However, petroleum refinery activities that would have to start after the receipt of crude oil for its quality upgradation. The presence of sulfur element in crude oil would obviously instigate corrosion issues during the refinery process, which intends to cause deactivation of catalyst in minimal time. Subject to have various forms of sulfur, specifically thiophenic form, that is C4H4S, would really be a considerable challenging factor due to difficulty in removal of the element from its complex structure. As the legislation has put up a stringent regulation of sulfur level less than equal to 10 ppm, EEA 2019, the refineries would force to incorporate physicochemical, physicochemical treatments such as hydrosulfurization, which combines high temperatures and pressures to remove unacceptable sulfur element from crude oil. Crude oil, sweet and sour. In crude oils, the proposition of sulfur is found to be the most abundant element next to carbon and hydrogen. Most of the sulfur compounds present in crude oils are found to be as organosulfur compounds, which would have to exist in four main classes such as Mercaptans or Thiols, that is acidic in nature, disulfides, sulfides, and thiophenes, all three are non-acidic type. However, the inorganic group so far been exist in crude oil is basically characterized by the presence of elemental sulfur, hydrogen sulfide, and pyrites. Pyrites is naturally occurring sulfide mineral which comprised of the elements iron and sulfur forming iron disulfide, that is FeS2, which thus to be in dissolved form or suspended state in crude oil. Complete proposition of sulfur content is therefore to be expressed as weight percent of sulfur in crude oil. The concentration of sulfur in crude oil is typically found to be in the range of 0.03 to 5% by weight. As an usual practice, the level of sulfur concentration in crude oil would have been indicated by the terms sweet and sour. In crude oil, the presence of sulfur element in the form of aliphatic and aromatic organosulfur compounds would have been generalized as the major impurities. If there would have been any occurrence of oil combustion, these organosulfur compounds are thus to be converted as harmful SOx gases. Organosulfur compounds would generally be classified as acidic and non-acidic. Among aliphatic and aromatic sulfur compounds in crude oils, it is thus to be categorized that the mercaptans or thiols are acidic while sulfides, disulfides, thiophene, and other thiophene derivatives are non-acidic. Mercaptan sulfur is a class of organic compound that can be derived as the substituted form of H2S, in which one of the hydrogen atoms is thereby to be replaced by a hydrocarbon group. Just as hydrogen sulfide, the mercaptan sulfur would have also the acidic properties. Again, I repeat, just as hydrogen sulfide, the mercaptan sulfur would have also the acidic properties. But rather than H2S, the acidic behavior of mercaptan sulfur would thereby less prominent and be of more indicative towards the nature of hydrocarbons as due to increase of the hydrocarbon chain length. So, due to have the hydrocarbon molecule in mercaptan sulfur, the acidic properties of the element would therefore be much weaker than that of the H2S. The generic formula is R-SH, where the SH group is called a Mercapto group, which thus to be bonded with R, where R represents the alkyl or aryl group of hydrocarbon chain. Mercaptan sulfur, also known as mercaptan, is rather naturally occurring element in crude petroleum, and usually there would have been exhibited as different forms of mercaptans present in crude petroleum. The forms are as follows. 1. Methyl mercaptan or methanethoyl, that is CH4S, that is tends to CH3SH. Ethyl mercaptan or ethanethoyl, that is C2H6S, that tends to CH3CH2SH. Propyl mercaptan or propanethoyl, C3H8S, that can be represented as CH3CH2 square, the CH3 CH2 square SH. Butyl mercaptan, that is butanethoyl, that is C4H10S, that represents CH3CH2 cube SH. Amyl mercaptan, that is 1-pentanethiol, that is C5H12S, CH3CH2 4 to the 4 SH, and more complicated variants. See the structural configuration. Formula structure for different forms of mercaptans. Methyl mercaptans, CH3SH. Ethyl mercaptans, CH3CH2SH. Propyl mercaptans, CH3CH2 square SH. Butyl mercaptan, CH3CH2 cube SH. Last, amyl mercaptan, CH3CH24 SH. Mercaptans are the organic thiol compounds with having the molecular structure of carbon, hydrogen, and sulfur. These chemical compounds are detectable at concentrations as low as 10 parts per billion. A Mercaptan group that refers to a functional group containing a sulfur atom bonded to a hydrogen atom. Hydrogen sulfide H2S and mercaptans both are toxic and corrosive. Higher be the percentage of these two, then the subject crude oil is considered to be sour. Higher be the percentage of these two, that is hydrogen sulfide and mercaptans. Those both are toxic and corrosive. Then the subject crude oil is considered to be sour. Mercaptans, as they are categorized with their acidic properties, so they would have to react with alkalis such as sodium hydroxide or caustic soda. Lighter part of mercaptans would have first to extract from the liquid hydrocarbons phase by applying a stream of concentrated caustic solution. Again, I repeat, lighter part of mercaptans would have first to extract from the liquid hydrocarbon phase by applying a stream of concentrated caustic solution. For further removal of the stronger part of the mercaptans and just to expedite their solubility, it is rather to add some certain solvent such as potassium isobutyrate, that is C4H7KO2, and sodium sodium chrysylate, that is C7H8O Na with caustic soda solution. Again, I repeat, for further removal of stronger part of mercaptans and just to expedite their solubility, it is rather to add certain solvents such as potassium isobutyrate, that is C4H7KO2, and sodium chrysylate, C7H8O Na with caustic soda solution. However, catalyzed oxidation reactions that would have been achieved by injection of air through the mixture, and the process ultimately may have to convert the mercaptans as contained into disulfide oils. Traces of hydrogen sulfide and alkyl phenols would there have been removal from the crude oil when the oil is treated through a stream of concentrated caustic solution in a packed column or other mixing devices. In both the cases, the mixture is allowed to settle down for a considerable period, and as the salts are thereby weakly bonded, which thus to be readily dissociated. The product is then to be washed through water. There are several methods that can also have to facilitate the desired extraction of such impurities. Most of the refineries are preferred to entertain treatment facilities with a mild hydrogenation process. It has been exhibited that some of the sulfur compounds have a relatively weak chemical stability, which would have been easily decomposed into small molecule sulfur compounds during the hydrotreating application of crude oil processing system. Hydrotreating or hydrogenating technology is one of the most acceptable technology to remove sulfur from the crude oil. However, some polar sulfur compounds would have a poor response and rather difficult to remove sulfur by applying the hydrogenating technology. In such a situation, the chemical structures of these polar fractions and their complexity of the molecular composition can be easily revealed through the application of high resolution mass spectrometry mechanism. High resolution mass spectrometry mechanism. Crude oil with sulfur concentration, if it is being shown to exceed 0.5% by weight, then the crude oil is supposed to be termed as sour crude oil. Whereas the crude oil containing less than 0.5% by weight, sulfur, is defined as sweet crude oil. The New York Mercantile Exchange, NYMEX, one of the most leading contract market in the world, has confirmed a benchmark of sweet crude oil containing a level of sulfur below 0.42% by weight. At the present context, the transportation of sour crude oil with higher percentage of sulfur would have become an increasingly important environmental issue. As the price of oil is being identified by the amount of sulfur, so the separation of sulfur from crude oil would be one of the prime operational requirements in most of the refineries. Sour crude oil is also difficult to refine as the higher percentage of sulfur may always have the tendency to occur cold and hot corrosion and massive corrosive wear on metals. The ASTM D2622 has prescribed the most standard test method for determining all grades up to 5.3% weight sulfur of total sulfur content in crude oil by the process of wavelength dispersive X-ray fluorescence spectrometry. Sulfur, oxygen, and nitrogen in crude oils would have to exist in the form of heteroatoms, and their contents so far been exhibited in the heavy fractions of crude oils are being usually of much higher than those in the light fractions. The removal of these heteroatoms is of much importance for the processing and utilization of an intermediate distillate from the heavy crude oil. Let's stop here, further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share, and subscribe. Your subscriptions would encourage to post more videos. Also share your comments, feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.